Good evening, everyone. Today's session is on what is data structure, what are the different data structures we have, and how we implement these data structure in like C programming, right? So let us start with the session. We have already discussed about what is data structure. Whenever we want to store any data, whenever we want to organize the data in computer and save it, stored it in the memory of computer, and that is again in a way that is efficiently accessed, that no wastage of memory should be there. Different kinds of data structures are suited to different kinds of applications. So whenever we decide any data structure, that is decided according to the type of application we are using. Then we have like how to store the data, how to retrieve that data. That can be done in both the memories, like we can choose either main memory or it is done in the secondary memory. So whenever we are maintaining our data, whenever we are storing the data in the memory, we are going to basically use an data structure method that depends on the type of application. Right. So let us begin with this part. What are the classification of data structures we have? So it is, the first type is primitive or it could be non-primitive. So earlier the basic data structures that are available, that are coming under the section that is primitive, and even the derived from the primitive data structures, they are also coming under this category. Then we have another data structure that is based on their type of data, right? It could be homogeneous or it could be heterogeneous. When we have same type of data, like all the data is of numbers, so you may be categorizing into integers. If all the data are in a float, so they may be categorizing into another, but usually we have only homogeneous collection of data set in like we are using the data structure that is array, right? Whereas we have list, we have other structures also, other data structure which can hold any type of data, right? Then we have static allocation and dynamic allocation. So whenever the memory is allocated at the time of compilation or runtime, so that could be coming under the section that is static data or dynamic allocation of data. Then we have a linear structure or non-linear structure. Basically, it maintains a linear relationship between the elements, right? So it could be linear, it could be non-linear. So these are the classification techniques of data structures, right? So let us start with one of the technique and understand how it works, how it basically stores the data in the memory. Right. So let us start with that. First of all, understand what is data type. So data type is featured or characterized by set of values. You have some values, it has some type of data. Like the value is of any type. Like if I'm taking a name of a student, then it would be treated as a type, that is string, or it has a collection of characters. So it is falling under the category that is character. Suppose I am taking the age of a person, right? And it is in numbers obviously. So that means it is again having the data type that is integer. Or you may have other like you have weight, right? So weight could be 50.5, or you may say 60.5. It could be a decimal point number, so it could be treated in under one type of data. So deciding the type of data, it depends on the value, whatever the value is, right? A data representation which is common to all these values, and set of operations which can be applied uniformly to all these values. Suppose I am saying, can we perform arithmetic operations on a name field? No, because it's a string value. We cannot perform the arithmetic operations. Like if I'm going to ask you add Manvi with 2. So what do you mean by 2? If I'm going to ask, like CBSE has uh, increased, has given the grace marks to all the students, and they have given 2 marks, like whatever they are having in their subjects, add 2 numbers to that particular marks. So it could be possible because the number is in number, right? Because the subject marks is in numbers. You can add, you can perform arithmetic operations to it. So basically, it depends on the type of data which the variable is holding, right? Now let us move to the next thing. These are the different types of primitive data types, right? So what are those? Because whenever we implement any data structure, we need to have basics of any programming language. It could be through C++, it could be through C language. So we need to understand what are data types under this, right? The first is boolean, which holds the true or false value. The second is character, byte or int. That means you may have some name like that needs to be stored, right? And then you have some decimal point number that needs to be stored under the float type of data. Then each primitive type has what is will be having a set of values, a data representation and set of operations, right? So these are what? These are the primitive data types which we usually use in any programming language. Now, after this, there is abstract data types, which are basically, in simple words, we say it is an set of operations, mathematical abstraction, no implementation in detail. For example, if I am talking about list is holding the number of values, right? It could be a list can contain, like if I am going to ask, a list is having a name of the student, the address of the student, the marks of the student. So it is holding the number of values, right? Then there are like the sets, graphs and stacks are also the examples of abstract data types, right? Now let us see uh, what are the characteristics of ADT. ADT stands for abstract data type. Modularity. What do you mean by modularity? Basically, we decompose the program into smaller program. Suppose I am talking about there is a big program that consists of 1,000 lines of code. There are 1,000 statements in a program, and again what we are going to do is, and it is consisting of different functions. So like one function can be decomposed into further sub functions. So what we are doing is we are solving the problem by using the concept of modularity, right? So that like small modules can be debugged and tested, and then they can integrate it to have a full program. So easy to debug and maintain, easy to test also, easy to modify, and it's a group. Later on, we are basically integrating the all the modules. Then obviously, if we have some smaller modules, like you have decomposed the big module into small modules, what you can do is you can reuse those modules. You need not have to again and again test it and debug it and maintain it. Once you have made that program and you have tested that program, you just need to reuse that program with other modules, and then you can perform the integrated testing. Then we have, it's easy to change the implementation because everything is transparent to the program. Like if I want to change something in one function, that is a very small function, if I want to change that piece of code or a number of statements in single module, so I can change it, right? And then again I can test it and integrate with other modules. So these are some characteristics, or you may say some of the advantages of modularity. Then we have is how to implement it. The most important question that comes into our mind, how to implement this abstract data types. Now to implement this data ADT things, you need to choose a data representation. How to represent the data? It should be public, it should be private, it should be protected. How you are going to use that particular value, in which category it is lying. That it must be able to represent all necessary values of the ADT. It should be private. Like suppose I am defining a variable that is a password. Obviously, that should not be a public variable. It should be defined as a private variable that cannot be accessed by other people, right? Then the most important thing is, after data representation, we have an algorithm. Now, what is an algorithm? We have already understood the series of steps which implement some logic and for a specific task, and we are getting some output from that particular algorithm, right? We need to have a pseudocode, and after that we can implement that pseudocode in some programming language so that we can get the output. Right. An algorithm for each of the following necessary operation must be consistent with chosen representation. All auxiliary, all helper operations that are not in the contract should be private. So what we are going to do is, we are performing the operations on an algorithm. Remember, once other people are using it, it's necessary to add this functionality. So these, what are these? Basically, when first of all we have a data representation, when then we have an algorithm to be used, to be executed on that, to be the logic should be implemented, and then we check out the data structure. So let us see this. The first data structure that we are going to use is a list. So list is an ordered sequence of data items in which data items go what we call as elements. Elements in the list. Suppose I am saying list is having, there is list name is A, and it is holding the items, that is A1, A2, A3, A4, and so on, and AN. So n is the size of that list. Size of an empty list is obviously 0. If it is an empty list, there is no element in the list, it should be, the size of that list should be 0. And how we are increasing the elements, how we are basically, you may say what is the index of that. If I am going to ask like A1, then you may see on my screen A1, then A2. So if I am treating A1 as AI, so the next element would be AI plus 1. So if we place this AI plus 1 that is succeeded by AI, or AI minus 1 that is preceded by AI, when we call it as like I want to access the preceded, the not the uh, you may say successor. I want to check out the predecessor. So I may be using what, A minus 1. So position of AI is I, starting with I. The first element of A, that is A list, is A1, that is called the head, and the last element is AN, that is called the tail. So this is how we define a list data type, right? Let us see what are the operations that we can have, that we can perform on a list. We make a empty list. First of all, we make a empty list. Then we can print the values. If we have any values in the list, we can print that value, print the elements of the list. If we want to find any element in the list, we can find it. We can find any kth term also. Then we can insert the elements in the list. We can delete the element from the list. We can have what will be the next value, what would we get the previous value. So these are the number of operations that we can perform on list, right? Then we have how to implement this list. Now, there are number of ways, there are number of data structures through which we can implement the concept of list data type. The first is arrays, the second is linked list, and the third is cursors. So cursor is basically linked list using arrays. Most of the time we are going to use linked list because linked list has its own advantages. So one by one we are going to access both the things. The first thing, that is arrays, and the second thing, that is linked list. So starting with the arrays, arrays is a static data structure that represents a collection of fixed number of homogeneous data items. Now when we say that homogeneous data item, let me tell you what is homogeneous data item. Like suppose I am saying A, suppose I am saying it's an A and it is holding some values. Now homogeneous means A is holding only numeric values. A, 1, 2, then 3, then 4, and then so on. So homogeneous means this list This list that is containing the elements should be in digits, should be in numbers only. You cannot take it as a characters. You cannot take it as a any other data type except integers. So whenever we define the arrays, arrays may we only define the homogeneous collection of data. It's basically a homogeneous collection of data items. And again, a fixed size index sequence of elements all of the same time. Again, I am repeating, we are holding the same type of data. It is not possible like I am writing one, then I am writing my name, then I am writing some address. No, it is not possible, right? The individual elements are typically stored in consecutive memory location. So they are whenever a array is stored in the later slides also you may see the arrays are stored, the elements of the arrays are stored in a consecutive memory locations. It cannot be like one element is here and the other element is somewhere else. No, it is once the array is created, it is holding the values, it is storing the values in a consecutive memory locations. The length of the array is determined when the array is created. Yes, so we need to specify, we need to specify the size of the array at the time of initializations, and it cannot be changed. You cannot change because you are putting some elements into it, right, later on. So the size of the array is at the same time it should be mentioned. Any component of the array can be inspected or updated. So you can perform number of functions on the array also. So any component, any item of the array can be inspected or updated by using its index. This is an efficient operation. Like you have different asymptotic notations. Later on we will be learning about what is big O notation, what is omega, what is so there are number of notations behind that. We will be learning in how to calculate the time, how to check the efficiency. So we will be having how to calculate the time, right? The array indices mean indexes. The array indices may be integers. So whenever we have a0, if I am talking about in the previous slide, it is a0 or a1. It could not be a0.0. So the memory location is always represented in integer number only. You cannot have other than that, right? The lower bound may be 0. So in C or in Java languages, we say that the first index of the array is a0, or you may say the lower bound of the array. Different types of arrays. Now there are number of types of array according to the data. We usually select the type of array also. So the first type of array is one dimension array. When we have only single index, right? Only one index is used. Like suppose I have defined one array that is a 10. So I may be defining only one dimension. If I am defining rows and columns, I may be using more than one index. That means it is multi-dimensional array. Then we have static array. The compiler determines how memory will be allocated for that array. So it is static array. Whereas when we have dynamic array, memory allocation takes place during at the execution time only. Right? It is not stated in advance. So let us see the example of one dimension static array, how to define it, what is the syntax of it. So the first is element type, what is the type of data that the element is having in the array. Then space array name, then capacity is the size of the array. How many elements will you have in your array? Then the second is second type of thing, like you can use type of array, data type of array, then array name, capacity equal to you initialize at the time of declaration of array. So you initialize it with some values. Like in this we have initialized it with 9. The first int b, and b is holding how many values? That are 5 values in that. Right, and the same thing we have is at the time of declaration we are initializing it with 1968. So we are initializing the at the time of declaration itself. So we are initializing the array with 1968, 12, 45 and 72. This is how we declare the array as well as we initialize that array. Then how we print the output in an array. So we usually have a function. We will be doing the functions also in different programming language, right? Function is to perform a specific task, like suppose void is the return type, display is the function name to display the data on the screen. Then we have two arguments, one is the array and the second is number of values. What are the values of that? And then what we have taken a loop, that is for loop. Int is, that means the data type of I is int, which is initialized with 0, starting with 0, and the size of, like, what is the condition, till what number it is going to run, till less than the number values, and then increment it with, like, I plus plus is I plus 1. So this is how we use for loop for printing the values in the array, right? And then we write that, like, we are using with cout for printing the statement, and then we write down the array index, array, and then I means the index of first element, second element, third element, till this loop will is going to execute till we reaches to the that should be less than number of values. Then we have the second data structure, second type of list is linked list. It is the linked list has its own importance and linked list has its own advantages also, right? So let us see how it works. Basically, like in a linked list, they are not adjacent in memory. Like in arrays, we have consecutive numbers, like the items are stored consecutively in the memory, whereas in a linked list the difference is only this, they are not stored consecutively in the memory, rather than it is stored where the memory space is free, it is stored there. And how a element is stored, like if you have defined and we can perform insertion and deletion in the array, but obviously the cost behind that is also the developer or the customer has to bear. Now how it works, let us see. Like suppose I am talking about a1, that is, and the second thing is, first is a1 and the second thing is address of the next data item. So address is 500 and at the 500 address it is written that a2. Then again A2, the next value is showing the address of the A3. So A3 ki value is 400. Again A3 is holding 666, that is the address of A4. And the last we have 0 to end the linked list. So let us start with singly linked list. How to do that? The first is data. You have data and next pointer is basically pointing to the address of next data item in the linked list. So suppose I am going to start with the first start pointer is pointing towards the head of the linked list and end pointer is going to have the null value at the data. So it is divided into two parts. The first is the data and the second is the address of the next variable. So this is how we represent it in memory, and it is basically it has its own advantages over arrays. So like this, we have taken one example. The variable is holding the value 2 and the address is 2184. So now we move to 2184. It is having the value that is 4 and the next value is 3225. So it is holding the address like this, right? And you can see behind that the memory locations are different. They are not stored consecutively. This is the basically where they have find the space of that particular type, they are storing that data, right? And again at the last of the linked list we have null to end the linked list. We don't have the address in the last element. Then we have what are the advantages of using linked list. What are the advantages? We have seen like they are stored in memory not consecutively. So if you have 10 items in the linked list, it is not like they are stored consecutively. No, they are not stored consecutively. They are stored as like one data item, then somewhere else it is stored, then somewhere else. So it basically saves the memory. Whereas when we have arrays, array stores the data items and the size of the array, like you have defined 5 items. So their consecutive memory spaces of 5 elements will be, uh, you may say, occupied by the variable. Whereas in linked list, this disadvantage of array can be basically overcome by this by using linked list. Need to know where the first node is. The rest of the nodes can be accessed. So the first advantage is the only thing you need to know the address of first node. If you get the address of first node, you can access, because first node is itself having the address of next item in the list. No need to move the elements in the list for insertion and deletion operation. So whenever we need to add any element, insert any element into the array, or delete any element, so you need to move the elements from the list. So in array, in linked list, there is no need to move the elements in the list for insertion and deletion operations. No memory wastage. That is the main and very, very important point. No wastage of memory would be there when we are using linked list, right? Now let us see what are the pros and what are the cons of arrays also. So arrays are directly supported by C, right? So C is very, you may say it is simple and easy to use language to represent the different data structures. If you want to implement any data structure, C is the best language to implement the data structure concepts. Provides random access. You can access any of the element, because by using the indexing, right? You have index. If I'm going to print I or A1, so it is going to directly print the value of this. Then again in later slides we will be knowing the syntax, how it is written. Like if I want to access the address of this A, you may write ampersand and then write the index of that particular item. Cons: the size determined at compile time. I told you the array stores the variables in the memory consecutively. Whether the array is filled or not, whether it is occupying any value or not, right? It is not. It is the disadvantage in case of arrays. Whereas in linked list, it is defined at the time of runtime only, not at the compile time. Inserting and deleting elements is time consuming, because you need to move the data item to get the free space, and then it is going to insert the elements in the array, right? So these are some advantages and these are some disadvantages of arrays. So now in this session, what we have learned about what is a data structure, what are the different characteristics of data structure, what is data type, how we implement, what is the basic concept behind arrays, what is the basic concept behind linked list, right? So in the coming series we will be learning about more about how to implement that in like using C language, either it is array or either it is a linked list. Let us see what are the advantages of linked list. Size determined during runtime. I told you it does not. The main advantage of using linked list is uh, avoids wastage of memory. Inserting and deleting elements is quick. It is very quick because we know the address of the next variable. We just put that part next pointer करके and we can directly insert or delete the uh, elements. No random access. It is the disadvantage of that. A user must provide programming support. Yeah. So you need to have some expertise, then only you can use linked list, because you have a simple knowledge of pointers, how to manipulate the variables. This thing you must know before using linked list. I hope all of you have enjoyed this session, right? And let us conclude this part also. What are the application of list can be used to store records sequentially, for creation of stacks and queues, for polynomial handling, to maintain the sequence of operations, for do or to undo in software, to keep track of the history of websites visited, right? On Google we see the history, how it is maintained. It is the list itself. So using list we can have number of advantages and number of disadvantages also. right? So meeting you in next session. Hope you like this session, right?